The practice of semen retention, which involves abstaining from ejaculation, has long been a subject of both historical interest and contemporary debate. Rooted in various cultural, spiritual, and health-related traditions, it has been associated with a multitude of supposed benefits for physical and psychological well-being. Among these claims is the assertion that semen retention can lead to reduced levels of certain hormones, notably prolactin and cortisol. To critically assess these claims, it is essential to delve into the scientific understanding of these hormones, the physiology of ejaculation, and the broader implications of semen retention on hormonal balance. Prolactin, a hormone produced by the anterior pituitary gland, is known for its role in lactation in females. In males, it regulates aspects of the immune system and reproductive system development. Notably, after ejaculation, prolactin levels in males experience a significant increase. This rise in prolactin is believed to be linked to sexual satisfaction and the refractory period, the post-orgasmic phase where achieving another erection is physiologically impossible. On the other hand, cortisol, often labeled as the stress hormone, is synthesized in the adrenal cortex. It plays a critical role in various bodily functions, including metabolism, immune response, and managing stress. Its secretion is characterized by a diurnal rhythm, peaking in the morning and gradually decreasing throughout the day. Importantly, cortisol levels are highly sensitive to both psychological and physical stressors. The hypothesis that semen retention affects prolactin and cortisol levels is based on the understanding that ejaculation triggers a temporary increase in prolactin. Therefore, it is theorized that avoiding ejaculation could result in consistently lower prolactin levels. However, this perspective simplifies the complexity of the endocrine system. The secretion of prolactin is influenced by a range of factors, including sleep, stress, diet, and overall health. The body's natural homeostatic mechanisms work to maintain hormonal balance, suggesting that any long-term reduction in prolactin due to semen retention may be offset by physiological adaptations. In the case of cortisol, the connection to semen retention is less direct. Cortisol levels fluctuate with stress, and the practice of semen retention could theoretically alter these levels depending on its psychological impact. If semen retention leads to increased psychological stress, cortisol levels might increase. Conversely, if the practice contributes to stress reduction or is part of an integrated approach to stress management, it could potentially help in lowering cortisol levels. While prolactin's role in lactation is well recognized, it also has other functions in the body, including its involvement in metabolism, regulation of the immune system, and behavior. Elevated prolactin levels, outside of the context of post-ejaculatory response, can have various effects, such as decreased libido, infertility, and in some cases, galactorrhea, the production of breast milk in individuals not breastfeeding. The mechanisms behind prolactin's actions are complex and involve interactions with other hormones such as dopamine, which inhibits prolactin release, and estrogen, which can stimulate it. Thus, while semen retention may influence prolactin levels transiently, the interconnected nature of the endocrine system means that the effects of such a practice on prolactin are not straightforward and are influenced by a multitude of factors. Cortisol's role in the body extends beyond the management of stress. It is vital for the maintenance of blood sugar levels, regulation of blood pressure, reduction of inflammation, and assistance in memory formulation. The hormone follows a circadian rhythm, which not only affects its levels throughout the day, but also its responsiveness to stressors. Chronic stress can lead to sustained high levels of cortisol, which can have detrimental health effects, including immune suppression, hypertension, and increased abdominal fat. Therefore, while semen retention may potentially influence cortisol levels through stress-related pathways, the overall impact of this practice on cortisol dynamics would also be influenced by an individual's circadian rhythm, lifestyle, and exposure to chronic stress. Given the intricate web of hormonal interactions, It is clear that the relationship between semen retention and hormonal levels is not a simple cause and effect scenario. The homeostatic mechanisms that regulate hormonal levels are robust and can compensate for short-term fluctuations. Additionally, individual differences in physiology, psychology, and lifestyle choices further complicate the potential impact of semen retention on prolactin and cortisol levels. Research into these areas is ongoing, and much remains to be understood about the nuances of these hormonal relationships and the long-term implications of practices like semen retention. The scientific literature to date primarily focuses on the immediate effects of sexual activity and ejaculation on hormone levels. There is a notable scarcity of rigorous research specifically examining the long-term hormonal impact of semen retention. Existing studies often have limitations in terms of sample size, methodology, and scope, making it challenging to draw comprehensive conclusions about the long-term hormonal effects of semen retention. The psychological effects of semen retention, such as perceptions of increased self-control, heightened confidence, and mental clarity, are frequently reported among practitioners. These psychological states can have an indirect influence on hormonal balance, given the intricate link between the endocrine and psychological systems. Moreover, semen retention is often practiced alongside other lifestyle changes, such as meditation, regular exercise, and dietary adjustments. These factors independently influence hormonal regulation and overall health, thereby complicating the attribution of any hormonal changes to semen retention alone. The discourse on semen retention and its hormonal implications must also factor in the neuroendocrine system, which acts as a bridge between the nervous system and the endocrine system. Neurotransmitters and neuropeptides play crucial roles in this interface, affecting hormonal release and regulation. For example, the neurotransmitter dopamine has an inhibitory effect on prolactin secretion. Engaging in activities that elevate dopamine levels, such as exercise, certain dietary choices, and even the psychological rewards of self-discipline from semen retention, could theoretically modulate prolactin levels. However, the extent to which semen retention alone influences this dopaminergic-prolactin relationship remains largely unexplored in the scientific literature. Furthermore, the role of sex hormones like testosterone and estrogen must be considered when discussing semen retention. Testosterone, in particular, has been a focal point of interest regarding semen retention, with some suggesting that abstaining from ejaculation could increase testosterone levels and thereby enhance various aspects of male health and behavior. However, the evidence on this matter is mixed. Some studies suggest that testosterone levels may experience a temporary spike around the 7th day of abstinence, but more research is needed to understand the persistence and physiological relevance of such changes. The impact of semen retention on mental health and cognitive functions also warrants attention. Some anecdotal reports claim improvements in focus, concentration, and cognitive capabilities with semen retention. The biological underpinnings for such claims could involve the modulation of hormone levels, including testosterone and cortisol, which have been linked to cognitive performance. Testosterone is known to influence brain functions, such as spatial abilities and memory, while cortisol, in chronic high levels, may impair cognitive performance due to its neurotoxic effects. However, the direct relationship between semen retention and cognitive enhancement has not been thoroughly investigated, and such claims should be approached with caution until more empirical data is available. Lastly, it is important to consider the broader psychosocial context in which semen retention is practiced. Cultural, religious, and personal beliefs about sexuality and self-restraint can significantly influence an individual's experience and the outcomes associated with semen retention. The placebo effect, or the psychological benefit derived from the belief in the efficacy of a practice, could also play a role in the reported benefits of semen retention. The interplay between these psychosocial factors and physiological responses is complex and can confound the interpretation of any changes observed with semen retention. While semen retention may have certain effects on hormonal levels, particularly prolactin and cortisol, the practice is embedded within a complex biological and psychosocial framework. The existing scientific evidence does not provide a definitive answer to the long-term hormonal effects of semen retention. Thus, further research, with rigorous study designs and larger sample sizes, is necessary to elucidate the physiological and psychological dimensions of semen retention and its potential implications for hormonal health. Hormonal regulation in the human body is a complex and dynamic process, influenced by a wide array of factors beyond sexual activity.